Hey everyone, welcome to our discussion. Today we're diving headfirst into the electrifying history of electricity, from ancient observations to the digital age. It's a wild ride, so buckle up. What's the very first thing that comes to mind when you think about electricity? Is it lightning, a light bulb, something else entirely?
For most people, I think the first thing that pops into their head is probably a light bulb. But the story of electricity is way older than that. It all starts with a simple observation thousands of years ago about a material called amber. Imagine rubbing a piece of amber with fur. It attracts small things like feathers and dust. That's static electricity, and it's where the whole story begins. Wow, amber and fur? That's surprisingly simple. So who made this amazing discovery? Was it some kind of super scientist with a fancy lab?
Not exactly. It was Thales of Miletus, a Greek philosopher around 600 BC. He didn't have a lab, but he had curiosity. He noticed this strange attraction and documented it. The word electricity itself comes from the Greek word for amber, electron.
That's incredible. So after Thales, did people just keep rubbing amber for centuries? Did nothing else happen?
Well, not exactly. While the understanding of electricity remained pretty basic for a long time, other civilizations noticed other electrical phenomena. They knew about magnets, for example, but they didn't connect them to electricity at the time. It was a slow burn, a gradual accumulation of knowledge.
So when did things really start to heat up? When did people start to seriously study electricity?
The real breakthroughs started during the scientific revolution in the 17th and 18th centuries. Think of names like William Gilbert, who did systematic experiments with electricity and coined the term electrica, or Otto von Guericke, who invented the first electrostatic generator, a machine that could create static electricity.
A machine for static electricity? That sounds amazing. What did that allow scientists to do?
It allowed for much more controlled experiments. Scientists could now study electricity in a more systematic way, leading to more discoveries. For example, Stephen Gray discovered electrical conductivity, the ability of some materials to conduct electricity, while others act as insulators.
Insulators and conductors, that sounds like something we still use today. What other big discoveries happened around that time?
Charles Dufay discovered that there were two types of electricity, positive and negative. And then came the Leyden jar, invented independently by Peter van Musschenbroek and Ewald Georg von Kleist. This was the first capacitor, a device that could store a significant electrical charge.
A capacitor? Sounds complicated. What was its significance?
It was a huge deal. It allowed scientists to store and release large amounts of electricity, making more powerful experiments possible. It was like having a supercharged battery, even though batteries hadn't been invented yet.
And then there's Benjamin Franklin, right? The kite, the key.
Exactly. Franklin's experiments, including the famous, though debated, kite experiment, showed that lightning was an electrical phenomenon. He also proposed the one fluid theory of electricity and invented the lightning rod. He was a true polymath.
A true Renaissance man. So after Franklin, what happened next? Did the study of electricity just stop?
Far from it. The 19th century was a golden age for electricity. The invention of the battery by Alessandro Volta was a game changer. It provided a continuous source of electrical current, unlike static electricity.
A continuous source of electricity, that's what really made things take off, right?
Absolutely. This led to the discovery of electromagnetism, the connection between electricity and magnetism. Hans Christian Ørsted discovered that an electric current could create a magnetic field, and André-Marie Ampère described the relationship mathematically.
And then came Michael Faraday, a true giant in the field.
Yes. Faraday discovered electromagnetic induction, the ability to generate electricity from magnetism. This was a monumental discovery, paving the way for electric generators and transformers. He also developed the concept of lines of force to visualize electric and magnetic fields.
So many amazing discoveries. It sounds like the 19th century was all about understanding the fundamental principles of electricity. What about practical applications?
The late 19th century saw the practical application of electricity explode. The invention of the light bulb by Thomas Edison and Joseph Swan revolutionized lighting. Electric motors started replacing steam engines, and the development of power grids allowed for widespread electricity distribution.
The war of the currents between AC and DC must have been quite something.
It was. Edison championed DC, while Tesla and Westinghouse pushed for AC, which ultimately won out because of its efficiency in long-distance transmission.
And what about communication? How did electricity change that?
The telegraph and the telephone, both using electricity, revolutionized communication, shrinking the world, and speeding up information exchange.
So the 20th century, what big changes did that bring?
The 20th century saw the rise of electronics. The invention of the vacuum tube was a major breakthrough, enabling amplification and switching of electrical signals. This was crucial for early radio and computers.
And then came the transistor, a tiny revolution.
The transistor was a game changer. It replaced bulky vacuum tubes, making electronics smaller, more reliable, and more energy efficient. This paved the way for integrated circuits, or microchips.
Microchips, the heart of modern electronics. What's the impact of all this?
The impact is immense. Transistors and integrated circuits fueled the digital revolution, leading to the personal computer, the internet, and smartphones. Electricity is the backbone of the digital age.
And what about the future? Is there anything new on the horizon?
Absolutely. There's a growing focus on renewable energy sources for electricity generation, solar, wind, hydro, and geothermal. Developing sustainable and efficient ways to generate and distribute electricity is crucial for the future.
So from rubbing amber to powering the internet, the story of electricity is truly amazing. It's a testament to human ingenuity and our relentless pursuit of understanding the world around us.
It's a story that's still being written, and it's a story that will continue to shape our world for generations to come.
This has been a fascinating discussion. Thank you.